Welcome to the Engineering Update. I'm WDD's Editor-in-Chief, Janine Mooney. In this week's episode, robots will take away your trash, increasing the efficiency of solar panels, and drones build a rope bridge autonomously. Volvo is collaborating with companies and universities in Sweden and the US to bring the robot-based autonomous refuse handling, also known as ROAR, to life. The robots will be built to help garbage truck operators with heavy lifting. Gone will be the days of men hopping off the back of garbage trucks to collect your excess trash. Many universities will be aiding Volvo with the design, including Penn State and Chalmers University. The students will develop the graphics, communication systems, control panel for the truck driver, design the operating system, and even design the robot. Waste disposal company Renova will take care of designing the actual vehicle. The robots will take direct instructions from the truck's operating system, which will be supervised by the truck driver. They'll collect the garbage bins straight from the sidewalk, bring them to the truck, and empty them while keeping noise levels at a minimum. This autonomous technology will eventually be seen in many applications beyond garbage collection, but for now they have plans to test the tech in June 2016. And then eventually, when we finally get that whole self-driving vehicle thing down, the whole process could potentially become autonomous, an interesting debate that I'll steer clear of for now.
A group of scientists has created a new technique for improving the efficiency of solar panels, and they are inspired by their own heads. Part of the problem with solar panels is that the hotter they become, the less efficient they are at converting light photons into energy. You can see how that would be problematic. But 3 Stanford engineers have figured out a unique solution to that problem. They created a thermal overlay from a thin patterned silica material that you put on top of a regular solar panel. The material allows sunlight through, but captures and emits thermal radiation from infrared. The phenomenon that inspired the engineers is actually pretty basic. When you walk around, you emit energy in the form of heat from the top of your head, which radiates into space as infrared light. This project is based on another project the 3 engineers did, where they developed a material that radiated infrared heat into space without warming the atmosphere. They used that paper, presented in Nature, to create this new material specifically for solar panels. Experiments have shown that the light can pass through the material, but that the solar absorber beneath the material was cooler by as much as 23 degrees. Though they're still working on a small scale, the group believes they can create the material in quantities that will be useful for large solar arrays in dry, clear environments. They're also looking to expand into any application that needs to remain cool, like a car roof on a hot day.
Researchers at the Institute for Dynamic Systems and Control have been looking for ways that flying construction robots can be programmed to autonomously build structures. In 2011, the researchers taught drones to use mathematical algorithms to translate digital data into flight paths, arranging bricks into a 20-foot tall tower. In their latest accomplishment, the researchers successfully programmed 2 quadcopters to build a footbridge autonomously, strong enough to carry the weight of a human. Each aircraft was equipped with a motorized spool and plastic tubes that allowed it to dispense Dyneema, a low-weight, high-strength material suitable for aerial construction, also found in whiteboards. The drones laid out stretches of the rope, weaving knots, links, and braids using 394 feet of rope across 9 segments, making the total bridge length 23 feet. The locations of the scaffold at both ends of the bridge were measured manually prior to construction. Otherwise, the quadcopters constructed the entire structure without human intervention during the process. However, in order to make this all possible, there was some work done by humans beforehand. A motion capture system allowed flight paths to be adjusted on the fly. This monitored vehicle position and, taking into account force applied to the quadcopters as the rope is deployed, computer algorithms that spat out commands and sent them to drones over a wireless network. Still, it's pretty impressive, and the researchers say this is the first time quadcopters have autonomously built load-bearing structures capable of supporting humans. That's all for this week's Engineering Update. Be sure to check in on Twitter and Facebook and watch past episodes at ecedmag.com. For the ECN channel, I'm Jamie Wisniewski, and this has been your Engineering Update.
Oh yeah, woo!
Array.